Welcome back to the Advanced Microcontroller series. In today's session, let us discuss about microcontroller interfaces with matrix keypad. And here is the agenda: Introduction, Interfaces. It is used when the more number of user inputs is required and still want to save the some controller IO lines. So when you need more number of user inputs, then you can use this matrix keypad, and you want to save the some controller IO lines, then you can go with the matrix keypad. So it is also made up of tactile keys. So in this condition, over digital keypad, we can use matrix keypad. And why it is called matrix keypad? So it is designed in the form of rows and columns. So it uses rows and columns concept. That's why it is called matrix keypad. Most commonly used in telephonic, calculators, digital lockers and many more applications. So let's see how this matrix keypad works. So here we having the first diagram. So here total we having 3 diagrams, right? So in the first diagram you can see this is a tactile key. So this matrix keypad is also made up of tactile key. If we press this tactile key, what will happen? The connection, here you can see the connection towards ground. So what will be the signal at this pin? So if the switch is open, what will happen? This is the floating line, isn't it? So let's assume this switch is closed. Then what will happen? The current flow towards the ground. So what will be the signal at this pin? So it is not connected to VDD in this line, right? So okay, let's connect with the VDD. Now, so here in this case we having pull up, isn't it? So now after connecting, after adding VDD, pull up, what will be the signal here? What will be the signal? So assume now switch is closed, then current will flow towards the ground via this switch. So switch is closed, connection is complete, then it will flow like this current, isn't it? So if there is no switch pressed, what will happen? Flow like this, isn't it? So if there is no switch closed, then current will flow like this. So if switch is pressed, then connection is complete, then it is flow towards the ground. So what will happen? So here, so when you press switch 1, don't you think it fall down to 0? Yes, it is 0 when you press. So okay, I'll erase it. So when you press, so okay, let me write again. When you press the switch, what will happen? Current will flow like this and this signal is 0. If I press switch 2, so here what we happen? Only one connection. Okay, so here you can see you pressed the switch and it is 0, right? Okay, let me consider more switches. So here we having 1, 2, 3, 4 switches. So if I press switch 1, what will happen? Current via switch 1, current will flow towards the ground, isn't it? So here what will happen? This signal is, this pin is 0. So in this case, so if I press switch 1 now, and this is not pressed, okay, this switch is open. So now I pressed switch 1, switch 2, not switch 1. Now what will happen in this case? The current will flow like this, isn't it? And then here what will happen? It is equals to 0. Again consider the switch 3. Now switch 3 is closed. Again current will flow like this, and here it is equals to 0. Here the signal is equals to 0. Same thing happens in case of switch 4. But here you can see, and here you can see this signal is 0, isn't it? Now my question, so here you don't know which is pressed. Here signal is 0. Can you assume which is pressed? The signal is 0, isn't it? Are you able to tell which switch is pressed? No, because if you press switch 1, in that time it is 0. Switch 2, in that time also it is 0. Switch 3, switch 4, in that time also it is equals to 0. So for that case we are having, so for that case we doing some changes in the circuit. So here you can see this diagram. So whichever you want to press the switch, that one you ground it, and rest of the switches connected to VDD. So here we connected rest of the switches to VDD. So here both sides of the switches are connected to VDD. So if you press switch 1, so if you press this switch, signal is 1. Then what will happen here? This is equals to 0, isn't it? So can we guess which switch is pressed? Out of 4 switches, which switch press signal fall down to 0? Only this switch, right? Switch 1. Only if I press switch 1, via switch 1 current flow towards the ground. If I want to press switch 2, then what we need to do? So we need to connect this switch 2 to ground. Rest of the switches connects to the VDD, isn't it? Then if I want to press this switch, again same thing we need to do. We need to connect this particular switch to ground, and rest of the switches connected to the VDD. In case of switch 4 also same. But the thing is, we can't do physical connection like this. So here we having switch 2, okay, and here switch 3, and here switch 4. So we can't do physical connection like this. So for this, here you can see this diagram. So here this side of switch is connected to the microcontroller. Whichever switch you want to read, provide it to ground. So here you can see, now whichever switch you want to read, provide it to ground. So here you need to pass the signal, whether you want to ground or VDD. Ground means signal is 0, and keep other switch to VDD. So if I press switch 1, then I need to provide here 0, and rest switches equals to 1. So now make sure you providing 1 means VDD to rest of the switches. So what happen in this case? Only user is press only switch 1, isn't it? And current flow towards the ground. Like this, current will flow towards the ground via switch 1. And so if I press switch 1, here what will happen? That is equals to 0. If you want to press switch 2, then provide 0 to only that switch and rest of the switches are 1. Same thing you need to do for the others. Here you can see no switch press happen here. So all are connects to the VDD. By seeing this diagram, can you guess how many rows and columns are there here? See here, this is row 1, row 2, row 3, row 4 and 1 column. So this is what? 4:1, isn't it? This is 4:1. So in our PICSimLab Simulator, we having matrix keypad, isn't it? So let me open the PICSimLab Simulator and let's see. So here in the PICSimLab you can see we having 1, 2, 3, 4 rows, 1, 2, 3 columns we having. So it is 4:3, right? 4 cross 3. So now let's come to here. So as we discussed it, so whichever switch you want to read, make sure that row is 0. So here you can see right now all switches, all rows are 1. So we are not able to read any switch. If you want to read the switch 1, then if you want to press switch 1, make sure that particular row is equals to 0. That is equals to 0. Then you are able to detect the switch press. So when switch 1 is pressed, then column fall down to 0. So here it is fall down to 0. If you want to read the second switch, so here we having switch 2. Then make sure that second row is equals to 0 and rest other switches should be equals to 1, and then the column fall down to 0, rest other switch 1. But in our case we not having, here you can see we having 4 switches, but we having only 1 column. But in our PIC microcontroller we having 3 column, isn't it? So okay, here you can see we having 1, 2, 3, 4 rows and 3 column. So here we having the diagram. So here we having row 1, row 2, row 3, row 4 and column 1, column 2, column 3. So now I am making row 1 is equals to 0. So this is the row 1, right? This is equals to 0. And if I made row 1 as 0, then what I can do? So here only this particular switch we can able to press, isn't it? 1, 5 and 9. And here if I do this particular second column is equals to 0 and I am able to do only this column switches, I am able to press. Here row 1 is equals to 0 and column 2 is equals to 0, are you able to tell which switch is pressed? Row 1, column 2, this one, 5th switch is pressed, isn't it? So assume now row 3 is equals to 0, rest other switches is equals to 1, and column, this not this one, column, this one, column 3 is equals to 0 and this is 1. Now this is row 3 and column 3, means 11th switch is pressed, isn't it? Here you are able to understand, but here what happened? If you press the switch, if you selected row 1 is equals to 0 and you also selected column also, but you, how you are able to tell which switch is pressed? Whichever switch connected to 0, that particular switch is pressed in this case. But here what happened? We have 4 rows and 3 columns. You have to check like this, right? Which row selected and which column selected, that particular switch is pressed. So here you can see, here this particular row, let's select this particular row as 0. Then we are able to do this one. To press, you can able to press this switch and here this column is selected. Now which switch is pressed? This switch, isn't it? So here also you need to write it as 0. But this is what? This is not onboard circuit. So our onboard circuit is having what? Here you can see, this is the onboard circuit. So let's discuss about this onboard circuit. Okay, so yeah, this is onboard circuit. Yeah, this is onboard circuit. I told this one is not onboard circuit. Yeah, this is, yes, this is also. So I hope you get how to connect this. So now here you can see in this diagram, okay, sorry for the confusion. This is not onboard circuit. Okay, this is not onboard circuit. So here you can see in the onboard circuit we having switches 1 2 3 4 5 6 7 8 9 star hash star 0 hash. Sorry for the confusion, I said by mistake. So this is the onboard circuit. Here you can see this is the onboard circuit. So here you can see the switch names are same, isn't it? 1 2 3 4 5 6 7 8 9 and hash 0, sorry, star 0 hash. So here columns are connected to the port B. RB0 connects, column 1 connects to the RB0, column 2 connects to the RB1 and column 3 connects to the RB2, and here rows are connected to port D. Row 1 connected to RD3 and row 2 connects to the RD2, row 3 connects to the RD1, row 4 connected to the RD0. So here you can see no switches are pressed, isn't it? All switches are open only. So we have to provide, what we need to provide? Pull up we need to provide like this. So we have to provide here pull up we need to provide. We need to connect to resistor and we need to connects to VDD. But so Whenever we programming, we have to enable pull-up. So this port B pin is having internal pull-up. We can enable that. So okay, before that let me create a table to detect switch press and refer the table while programming. So here, now in the first case, in the first case assume row 1 which is equals to, okay, let's assume all rows equals to 1 and all columns which is equals to 1. So what will happen in this case? Which switch is pressed? No switch is pressed. No switch press in this case. So it is release state. So now whichever switch you want to read, then the switch is 0, isn't it? And rest of the switches connects to 1. Now assume row 1 is equals to 0 and column 1 which is equals to 0. So now which switch is pressed? So here you can see this is row 1. All these switches, there may be a chance of pressing switches, all 3. But another condition is column 1 is pressed. So switch 1 is pressed. Did you get? So switch 1 is pressed. And in the second case, row 1 is 0, but here what happened? Column 2 is equals to 0. So here column 2 is equals to 0. Means what? Switch 2. Here you can see this is column 2, right? Switch 2 is pressed. In the third case, row 1 is equals to 0 and column 3 is equals to 0. Rest columns are is equals to 1. So in this case what happens? Switch 3 is pressed. So similarly you have to do all things. So this is what for switch 3. Now in the next case what happen? Row 2 is equals to 0. Means row 2 is pressed. When column 1 is pressed, then it is switch 4, isn't it? So here you can see column 1 and row 2, that is what? Switch 4. And column 2 is switch 5. And column 3 is nothing but switch 6. Similarly, you have to do row 3, row 4, row 4. Okay, the same thing. This is our onboard circuit. To connect 12 switches. So how many IO lines are used here? So here you can see for port B, in port B we are using 3 lines and in port D we are using 4 lines. Total we are using 7 IO lines. But in case of digital keypad, so in case of digital keypad, how many IO lines are used? So go back to the digital keypad. Here you can see how many IO lines are used here. So count it. How many IO lines are used? 12, isn't it? So here we use 12 IO lines. But in the matrix keypad we are using 7 IO lines. So input output lines. Now did you get this line? What they are saying? When more number of user inputs is required and to save the sum control IO lines, then you are go with matrix keypad. So the same thing we discussed in the first line of introduction. I hope you get it, what it is saying. Okay, this is about matrix keypad. Let me open the MPLab XID. So let's discuss along with the code. So now what is our plan? So when the switch 1 is pressed, this CLCD, we are using CLCD also. Why means it will display switch 1 is pressed like this. So whichever key is pressed, we are going to display using the CLCD. So yeah, let me open the code. Close the other projects, and here we having source. So under the source files we having the code. Go to the main function, and before that here you can see the columns are connected to the RB1, RB2, RB3, and rows are connected to the RD1, RD0, RD1, RD2, RD3. Columns are connected to RB0, RB1, RB2. But rows are connected to port D, not complete port D. It connects only 4 pins of port D. So how many peripherals are using here in our code? 2. One is CLCD and one is matrix keypad. In our project we are using 2 peripherals. So in the CLCD, but one more thing I wanted to tell. So these rows are connected to port D, isn't it? So rows are connected to port D from RD0 to RD3. So this is the connection of port D, isn't it? But columns are connected to where? Columns are connected to port B from RB0 to RB2. And here we also using what? Also we using CLCD, right? In CLCD we having data lines. We discussed it. Data lines are connected to port D. So that is connected from RD0 to RD7, isn't it? Data lines are connected to RD0 to RD7. So now don't you think here we having common connection? In port D we having common connection. Can we use it together? No, we can't use. So what is the solution? CLCD session is done, right? So in the CLCD what we discussed? Communication modes, 8-bit mode and 4-bit mode. So in 4-bit mode how many lines are used? In 4-bit mode we used RD4 to RD7, isn't it? So yeah, data ports are used from RD0 to RD7 in case of 8-bit mode, not 4-bit mode. So can we use this 4-bit mode CLCD? There is no common connection, isn't it? So we can use it. So we can use the 4-bit mode CLCD. So go to the code. So here you can see init CLCD, then control will go to the CLCD. So here you can see we are using 4-bit mode, isn't it? So 4 bits are processed. So here you can see so it's showing 4 bits are processed, isn't it? But you are not going to use the common pins. That's why here it's showing 4 bits are processed. This is what 4-bit mode, isn't it? Yeah, this is what CLCD, and this one we already discussed in the previous session about the initialization, CLCD put ch function and CLCD print function. And next control will go to the matrix keypad. So here we having the matrix keypad. Now we need to understand the initialization of this matrix keypad. So here you can see matrix keypad column port. So for the column we are using which one? Port B. So here you can see what it means. We using only RB0, RB1 and RB2, isn't it? So in the port D we having 8 bits. So what it means? 0x07 means what? So 8 bits are there, right? 1 2 3 4 5 6 7 8. So here we are considering this bits equals to 1. So that's why it is 0x07. Did you get now why it is 0x07? And here we using the OR operation. Okay, this operation. So here what we used, OR operation. And same thing here. Here for the rows we are using port D, and here RD0 to RD3 we are using. So here you can see this AND operation only clear last 4 bits. It only make the last 4 pins as output pins. Did you get why here AND operation used and why it is 0x0? So this columns having internal pull-up. So how to activate it? How to activate the internal pull-up? We discussed, right? So it's having internal pull-up. So how to activate it? So let's go to the data sheet and let's see. So it is connected to port B, right? So in the port B we need to activate the internal pull-up. Okay, it's loading. So go to the table of contents and here you need to search. No need to search. Here you can check where is port B. So in outputs, yeah, here we got ports. So in that we need to search port B. So here we having port B. So now what we are searching here, how to activate the port, this one pull up, not this one, port B, pull up. How to activate the pull up? Here you can see Each of the port B pins has a weak internal pull-up. So, how to activate it? A single control bit can turn on all the pull-ups. This is performed by clearing this RBPU, this bit. So, which is nothing but 7th bit of option register. So, we need to clear this bit to activate the internal pull-up. So, let's go to the code and use this. So, this is what here you can see, here you can see what it means, not of RBPU, right? Not of RBPU bit. We need to enable the internal pull-ups. Yeah, this is done. Now, here we need to making all rows high to start. Initially we are making all rows high. Then here what we are doing, only row 1 equals to 0, rest all rows are high. So before that, here go to the initialization. So here we used the CLCD print function matrix keypad, and this is line 1. It will print at line 1 and 0th position. So CLCD print, CLCD is used to print string, isn't it? And so here you can see key equals to read matrix keypad of level. So just like digital keypad, here also we having read matrix keypad function, and inside the function we are using level detection. So not edge detection. So you can use level detection or edge detection. It's up to you. Logic is same. And so here you can see key function and display key function. These are the macros. So read matrix keypad, it will come to here. Here you can see read matrix keypad. So same thing how we done in the digital keypad, same thing here we having. So if mode equals to level, directly keys are written. Else means otherwise it is state change, isn't it? Or edge trigger. So here what, key is not equals to all released and once. In that time we return key and make once equals to 0. Otherwise all keys are released. Once equal to 1. Nothing is true. All are released. But here what key are returning? Whichever key we press it, that key we are returning. By using this function. Which function? Scan keypad. So how it is scanning the key? So in the table we discussed already, right? Okay, let me go. Okay, let me go to the function. So here you can see if row 1 is selected, then we need to consider that is equals to 0. When row 1 selected and column 1 selected, then returns which one? Same thing we discussed, right? So here, yeah, if row 1, yeah, So here you can see row 1 is selected and column 1 selected, then switch 1 is pressed. If row 1 selected, column 2 selected, then switch 2 pressed. Row 1 selected, column 3 selected, then switch 3 pressed. Same thing for row 2. In that time we need to consider rest of the pins as high. So column 1 selected, switch 4, column 2 selected, switch 5, column 3 selected, switch 6. Same thing we have to do. So all condition fails means what? All keys are released. Return all released. If user press key 2, then it return 2. So I hope you get it how to use this one. So here you can see if key is not equals to all released, then CLCD print key equals to on line 2 zeroth position, it's going to print the same key. If you press switch 1, then it prints switch 1 is pressed, like that. So if you press switch 2, then it prints switch 2 is pressed. And if no keys are pressed, then what will happen? Control comes to here and it will tell no key pressed. And if you press any these symbols like star or hash, so here we using PICSimLab function. So in case of ASCII value, we are using PICSimLab function, star and hash. For user key 0 to 9, it used default key. So how it will print? It directly going to print on second line 0th position, it going to print directly. For star and hash, so it will print on the fifth position of line 2. So here you can see key plus 0. So 1 plus 0 equals to 1, isn't it? I hope you get it. For the keys it will going to print directly. For the ASCII values, it will print on the print using the PICSimLab function. If there is no key pressed, then it returns no key pressed. And this one also we discussed. And CLCD.H macros. This one we discussed in the previous session. For the data port we are using port D, and these are the data direction register. So that's all about the matrix keypad. Okay, build the code. So I'm going to build like this: production, clean and build. So build is successful. Now go to the PICSimLab Simulator, file, load hexa file. So here I'm going to select matrix sources, distributive, default, production, hexa file. So here no key is pressed. So if I press switch 1, key 1 is pressed. If I press switch 2, key 2 is pressed. If I press star, key star is pressed. Same thing. I hope you get it. So that's all about the matrix keypad. In the next session, let us discuss about ADC. Thank you all.